Hello, I'm Julie Fontaine, Corporate Communications Manager at Nexus Automotive International. We are very delighted to host and to have a discussion with CG Neville from PHINIA about a circular combustion challenge. So welcome CG, I'm very happy to hear from you, and I will let you the floor to introduce yourself and tell us everything about Circular Combustion Challenge.
Wonderful. Thank you, Julie. I'm CJ Neville, the Senior Director of Product and Business Development at PHINIA Aftermarket. And I'm really looking forward to speaking with you today and looking forward to really sharing insights on combustion contributions to lower carbon mobility. Also actually mention that PHINIA has published our second sustainability report, which does highlight some of the steps that we've taken to strengthen our ability to measure and manage and overall reduce our environmental impact across the entire life cycle for our PHINIA products.
Thank you, CG. So now, why is cleaner combustions as a strategic necessity in the journey to carbon neutrality?
We really need a pragmatic path forward, Julie, one that would encompass incremental changes to drive carbon reduction. Internal combustion engines really are, an important contributor to this journey, in which a key driver in reducing overall environmental impact stems from the type of fuel that is used. So at PHINIA, we believe that ICE, internal combustion engines, when combined with alternative fuels, will and must remain really a viable and sustainable solution for the transition that we need to take towards carbon neutrality. Further thinking about our alternative fuels, including synthetic, bio, hydrogen, and other lower carbon or zero carbon alternatives, we can retain and complement key advantages of ICE, which would include things like faster refueling, lightweight, compact design, minimal cooling requirements, overall high indirect efficiency, and then, overall resilience to fuel quality and environmental conditions. That was a lot of words, but most importantly, this will also retain decades of investment in a mature internal combustion engine supply chain.
Thank you. It's very interesting, but I'm curious now, how can cleaner combustion accelerate the transition to carbon neutrality?
Yeah, Julie, I think it's really continued development of combustion systems, which serve as a critical bridge between our current fossil fuel infrastructure and zero carbon and lower carbon mobility. So it enables ongoing reductions in CO2 emissions from new engines in both road transportation and industrial energy generation, while increased use of lower carbon fuels will reduce emissions from the existing engines that will remain on our roads for many years. Ultimately, enhanced combustion efficiency coupled with these alternative fuels will be one of the pillars in long-term decarbonization. Overall strategy along with other alternative energy sources and propulsion systems, notably electrification, but not solely focused on this. So really new combustion management techniques can cut both tailpipe and pollutant emissions quickly, which avoids the need to wait years for a new infrastructure. So these innovative techniques that are already being employed today include things like advanced direct injection, variable valve timing, high efficiency turbocharging, and optimized after treatment systems. This pathway to decarbonization and cleaner air avoids locking in high emitting assets and ensures that investments in lower carbon or zero carbon fuels really don't come at the expense of really having operational efficiency.
Mm-hmm. And what use case industry will benefit the most from cleaner combustions?
Yeah, I think while all industries rely on electric power generation, there are many use cases in manufacturing, in heavy industry, and in transportation that really are not necessarily well suited for full electrification for really a number of reasons, and will therefore benefit from enhanced combustion efficiency, again, coupled with alternative fuels. So today, industrial production processes, off-highway applications and different sectors like aviation or shipping or heavy-duty transport, these all face a fundamental constraint, which is insufficient electrical infrastructure. Simply put, there isn't enough infrastructure at this time to support these industries as part of a fully electrified economy. It would require really significant investment in renewable energy generation and grid modernization, particularly to meet the demand from these energy intensive and honestly hard to abate industry sectors and long distance transportation. And then in terms of heavy duty transport applications, electric solutions remain costly and at times impractical. Battery weight and volume significantly reduce payload capacity, which is constrained further by maximum axle weight regulations designed to protect infrastructure. The fast megawatt charging facilities that would maintain the required operational efficiency will require significant investment, again, in these grid upgrades. Experience with car charging indicates that public fast charging is often as expensive as conventional fuels today.
Very impressive. Let's talk, if you allow me, to talk about technologies. Now, what technologies are most vital for the transition, from your opinion?
I'm so glad you asked that question, Julie. There are myriad solutions available to the market today that can accelerate our transition to that lower carbon mobility, which is truly the goal. This includes things like high pressure direct injection, which again mentioned earlier, enables ultrafine fuel atomization and more homogeneous mixtures, as well as a precise control of combustion phasing. So additionally, exhaust gas recirculation, EGR, solutions can lower peak combustion temperatures, which reduces significant NOx formation while being modulated dynamically for optimal trade-offs. Advanced ignition systems will also be critical to engage ultra lean or dilute mixtures reliably, which unlocks low temperature combustion regimes. I think, but beyond today's sort of near-term technologies, continuous innovation and technological development offer really promising prospects. So we at PHINIA envision a future in which fuel-flexible engines can seamlessly switch between fuel types. Meanwhile, we know that AI is such a key area of focus for many companies, including us. And that learning offers the potential for commercial fleets to self-optimize combustion parameters based on things like global telematics and driving profiles overall. That's something that can change or be modified in each area, in each region, or globally. We also see integrated renewable to combustion energy stations having a significant impact. For example, this could enable co-locating renewables, including things like wind and solar farms together, with e-fuel synthesis and lower carbon gensets provided via closed loop energy parks. Finally, additional things like advanced coatings and surface treatments, particularly those that are inspired by aerospace ceramics, could really push cyclic efficiency higher than our current levels. So all of these future cases can be really exciting. But the near-term technologies outlined can really cut emissions in hard-to-abate sectors today. Most importantly, these technologies will lay the foundations for a more resilient, lower-carbon combustion landscape of tomorrow.
For sure. And if we go back to the aftermarket, what could be the role the industry could play in building a more circular combustion economy?
Well, today, Julie, as you know, more vehicles are on the road than ever before. Global new light vehicle sales in 2025 are expected to rise 1.7% year over year, according to new forecasts by S&P Global Mobility. The average distance traveled also continues to increase. For example, in the EU, for total road freight, the average distance per ton is 141.6 kilometers, according to the European Commission. So the average distance traveled by commercial vehicles also in the US does tend to vary, but a common estimate for the daily distance traveled by a long-haul truck driver is between 500 and 700 miles. You couple all of this with one other statistic, and that is the average vehicle life continues to increase. So the lifespan of a light commercial vehicle in Europe, like a truck or a van, may range from 12 to 14 years. And the average lifespan of a commercial vehicle in the US is generally around 10 years or 1.2 million miles, according to, again, the industry analysts that we know at S&P Global. So all of this together means that older technologies contribute to most of these on-road emissions today. The aftermarket is uniquely positioned to contribute to reducing emissions. Key to this will be things like remanufacturing injection and electronic systems, which will reduce waste. We can also upgrade engines for higher efficiency and offer ongoing service and consumables that enable low carbon operation for these older vehicles.
Thank you, CJ. And I'm wondering, how can the aftermarket collaborate effectively with large technologies partners to support a circular economy?
Yeah, supporting the circular economy through the aftermarket demands, I would say, really strong partnerships with like-minded and innovative technology leaders. Collaboration around remanufacturing in particular presents an opportunity to accelerate the transition, again, by keeping old parts out of landfills and providing them with new life. This process represents a resource-efficient, very cost-effective, and more sustainable option for our aftermarket customers. Remanufactured fuel injectors, turbochargers, EGR valves, and other precision parts enable combustion engines to maintain optimal performance. And beyond this, remanufactured parts help keep engines in peak condition longer, which delays the need for full vehicle replacement and the accompanying waste and resource use. At PHINIA, we remain committed to delivering innovative solutions that address the unique needs of each vehicle segment. To fully leverage the benefits of our remanufactured parts in the aftermarket, it's essential that we collaborate closely with both OEMs and aftermarket players. Overall, efficient management across the value chain will enable our manufacturing plants to focus on remanufactured solutions alongside of new part production. So that delivers better cost, sustainability, and operational advantages.
I have a last question for you, CJ.
Of course.
How can we change perception of ICE to reinforce its role in the transition to carbon neutrality?
Yes, we actively engage with governments and stakeholder organizations to highlight the benefits of combustion technology combined with alternative fuels. This will retain the benefits of mature ICE technology and skilled service and technician resources while safeguarding established and resilient supply chains, as well as existing infrastructure and assets for ICE propulsion. Educating governments and company leaders about the role of lower carbon combustion technology will be an impactful first step, particularly through industry communities like Nexus, who will provide a non-biased view. Technology leaders also have a role to play in the education piece. At PHINIA, we're focused on repositioning ICE as flexible, as a lower carbon alternative powertrain, while we actively demonstrate our capabilities to function on a spectrum of fuels. This depends on the application requirements, but overall, we're finding ourselves educating the market on the fact that ICE can work alongside everything from e-fuels and hydrogen blends to biogas and ammonia. Another way we can collectively reestablish confidence in combustion is to publish transparent third-party lifecycle analyses. So these viewpoints should be able to compare benefits for next generation ICE, again, with e-fuel, with hydrogen or other lower carbon and zero carbon fuel options. We should also cooperatively consider launching pilot programs, including things like taxis or delivery van fleets or gensets that could use or improve these technologies. This would generate real-world performance and emissions data with key findings shared through open dashboards at industry events. And in closing, I guess, finally, we really engage with governments to promote targeted incentives, things like tax credits and lower carbon and zero carbon fuel standards, which reward operators for adopting a cleaner internal combustion engine technologies and the synthetic fuels. We believe it's important for regulators to phase in emission caps that account for fuel carbon intensity. So not just tailpipe exhaust, but really enabling parity across all powertrain types.
Thank you so much for this great discussion, CG. Looking forward to hear more from PHINIA. Thank you.
Thank you very much for the opportunity to speak with you today, Julie, and I look forward to the next chat.
Thank you.